Hello, hi. So today is my day to present the progress report of the PhD project. My title is In situ hydrolysis of epoxidation of hybrid mixture palm oil waste cooking oil for sustainable polyurethane production. So my name is Muhammad Zulkifli bin Abdul. My SV is Dr. Muhammad Jumain bin Jalil. Our QSB is Dr. Sabrina Safwan. Okay, next we go to the presentation outline. They have five to six chapters, which is introduction, literature review, research methodology, research discussion, published paper, and our Gantt chart, the study Gantt chart. So the background of the study. So mainly the study is focusing on the vegetable oil. This vegetable oil is made up from the palm oil and waste cooking oil. There are not as favorable renewable resources to substitute the petrochemical based product, which is non-renewable substance and also non-environmental friendly. Secondly, the epoxidation of palm oil acids, actually hybrid palm oil with the waste cooking oil acting as a green chemical precursor to produce the green oxygen ring. When the C double bond C, the forming acid chain are converted into the epoxide by addition of oxygen atom. The reaction is the in situ hydrolysis of epoxide to produce the polyoil and polyurethane. So basically in water, in this reaction, which is a side product from the performing acid formation, was used to react with the epoxide to produce the polyoil. Then intermediate product of polyoil will further react with isocyanate to produce the PU. So this chemical equation to produce the PU form, they have three chemical equation. Firstly is chemical equation of epoxidized oil, palm oil, pressed cooking oil. So normally we use the hydrogen peroxide. This one is hydrogen peroxide. We react with the formic acid to produce the performic acid and water. So after that, the performic acid will be react with the unsaturated fatty acid or oleic acid to produce the oxygen ring called the epoxidized palm oil acid, and side product is a formic acid. Okay. After that, the formic acid, the oxygen ring will be continue react with the water that produced from the here, produced from the first equation, react with the in situ, means that they have no addition of water, they have water from the side reaction, react with the oxygen ring to produce the polyoil. And then the equation is our polyoil is react with the isocyanate to produce the PU. Okay. Okay, so this block diagram to production of the polyoil. So oleic acid will react with the hydrogen peroxide and react with the formic acid with presence of the catalyst to produce the epoxide, oleic acid and water. Then this epoxide react with the water to produce the polyoil. Then third figure is a polyoil and isocyanate react together to produce the PU form. So the problem statement, they have four problem statement. So the first problem statement is in the past, epoxide and PU form are mainly produced from the petroleum-based sources, which is not sustained in long time. Then thus epoxidation of palm oil was introduced. However, plantation of vegetable palm oil causes conflict happen between the people in the ecosystem and also pollute the freshwater resources to ingredient people and disturb the biodiversity of endemic habitat. Second one, from the previous research also, the epoxidation 100% waste cooking oil produces a lower yield of RCO compared to fresh vegetable oil. But they have no research was conducted using the hybrid, which is a mixture of palm oil and waste cooking oil to produce the epoxide. Thus, the novelty method was introduced using the hybrid waste cooking oil, palm oil to increase the yield and RCO value. Third one, from previous research, alcohol is one of the chemicals to react with the epoxide to break the ozone ring. But alcohol itself tends to produce this side reaction and able to attack the non-epoxide ring causes the low of the polyol ring percent. Thus, in situ hydrolysis of epoxidation is the one of the novelty process because it can prevent the side reaction, and water is very selective to attack the epoxide ring compared to alcohol. Number 4, also from the previous research, they have lack of the public work to study on the kinetic to produce the polyurethane by hydrolysis based on the optimization of epoxidized mixture plus waste cooking oil. So they have 5 objectives. First one is to synthesis characterize epoxidized oleic acid based on different ratio of hybrid palm oil and waste cooking oil. Second one, to optimize the epoxidation of hybrid palm oil waste cooking oil using the Taguchi method. Third one, to study the effect of molar ratio between the hydroperoxide to the oleic acids, unsaturation molar ratio between formic acid to oleic acid, the speed and also the temperature. To formulate and synthesis the PU by using hydrolysis epoxide hybrid palm oil waste cooking oil to develop kinetic model of the PU production. The scope and limitation to carry out the study and to select the best ratio of hybrid palm oil waste cooking oil to produce the high RCO value. To optimize the epoxidation hybrid palm oil waste cooking oil using Taguchi method to validate the 4 parameters, which is hydrogen peroxide, molar ratio, formic acid, molar ratio, agitation speed, and reaction temperature to produce high RCO. Number 4, to study the synthesis of PU using the molar ratio of isocyanate and polyol via in situ hydrolysis of optimization of hybrid epoxide. Number 5, to develop the kinetic model for epoxidized hybrid palm oil waste cooking oil where the reaction system was assumed to be homogeneous. So there's a research gap. They have 3 days process. So based on the process, they have a research gap to production of epoxide hybrid palm oil waste cooking oil based on the optimum process parameter, production of vegetable polyoil via in situ hydrolysis process, and further react with the polyol to produce PU form. So this is a research gap for the process. For the knowledge of body of the knowledge, to give the additional knowledge on hybrid mixture palm oil waste cooking oil to produce epoxide, as well as not well explore for further replacement petroleum. They establish a new technique and substitute alcohol by using hydrolysis process to produce polyol and PU. Application use the Taguchi method as a tool to optimize the result to produce the PU form using the green method without use the petroleum and alcohol, then apply to industrial scale. Significant, they have 5. First, to offer the detailed understanding on situ epoxidation process using performing mechanism process. Second one, to explore the optimum parameter to produce higher RCO using the hybrid palm oil and waste cooking oil. Third one, to promote the emphasize the final product ozone for commercialized and large scale. Number 4, to develop cost-effective of PU production via in situ hydrolysis epoxide by hybrid palm oil and waste cooking oil. And then last one, to improve the overall design and able to meet the industry of the production of the polyol. Okay, so this is our literature review. So they have for fun is starting with the performing acid formation, how the performing acid formation is formed. First one is hydrogen ion from the epoxide will be bind together with the oxygen to form the protonated oxygen. Second, double bond between the C double bond O will be oxidized the electron to form the COH. Then center carbon will be facing protonated. Then after that, hydrogen peroxide OH as a nucleophilic will be attacked the electrophilic. Then the hydroxide ion will be oxidized H and form the C double bond O, while the OH ion will be bound with the H ion to form the water. Second, epoxidation will be happen when C double bond C will be oxidized to form the bonding with the oxygen and change to C single bond C. Then another bond from the oxygen will be formed triangle oxygen ring. Then the performing acid was formed as side product of oxygen. Third one is a polyol or PU formation. Oxygen become the protonated ones have the bond with the H plus. OH minus nucleophilic will attack the epoxide to deprotonate the OH and break the ozone ring, polyols undergo reaction with the isocyanate to produce the PU. So this is our research methodology. We will collect the sample and then do the epoxidation. And epoxidation actually is divided by two, is a Peresit mechanism. So after Peresit mechanism, we go optimization the parameter using Taguchi method. So at Taguchi method, we have manipulate the 4 item, ratio of HP to OA, ratio of FA to OA, speed of the reaction, and reaction temperature. After that, we can get the optimized epoxide of hybrid palm oil waste cooking oil. After that, we undergo the in situ hydrolysis optimization epoxide hybrid palm oil waste cooking oil to produce the highest value of polyoil. After that, we go to produce the PU form and need to compare with the current market quality. So method objective number 1, to synthesis and characterize epoxide palm oil waste cooking oil using the different ratio of palm oil waste cooking oil. Second one, the objective number 1, to study the compared relative conversion of ozone between the pure epoxide palm oil acid and also pure epoxide waste cooking oil. So we carry out 5 samples, which is 100% of oleic acid palm oil, 50-50 oleic acid palm oil to oleic acid waste cooking oil, 30-70 oleic acid palm oil to oleic waste cooking oil, 70-30 of oleic acid palm oil with the oleic acid waste cooking oil, and 100% oleic acid of waste cooking oil. So from this 5 tests, we have shown that 100% oleic palm oil is the highest RCO, absolutely, because we compare to palm oil waste cooking oil and 100% waste cooking oil. This is because WCO is have higher impurities and lower quality compared to fresh palm oil, and also the free higher RCO due to the high quality and carefully processed starting material to meet the optimum condition. Okay, so objective number 2, we run the Taguchi method. So we have run the design of experiment using 4 parameter and 3 level of reaction. So firstly, we have 3 level, 1 to 3, and we have 4 parameter, which is molar ratio of HPOA, molar ratio of FAOA, and agitated speed reaction. So we use 3 level, which is 0.5, 1, and 1.5 for parameter A. Parameter B, we use level 1, 0.5, level 2 is 1, and level 3 is 1.5 more. And for the parameter C, we use 200 for level 1, 300 for level 2, and 400 for level 3. And parameter D, we use the level 1, 45 degrees C, 65 degrees C, and 85 degrees C. Then we run the Taguchi method. Okay, so this is 9 experiment we have run. We based on the orthogonal array to build up this schedule. So after that, when we get the Taguchi method optimum 1, so we need to verify, to validate test on effect of molar ratio of HPOA, molar ratio of FAOA, speed and reaction temperature using optimum value. So they have the optimal result from the Taguchi method, manipulate one of the parameter and remaining parameter, keep constant to ensure to able to see the effect of the parameter based on the actual RCO yield. So this is a table that we have run. So objective number 4, we have physical, to study the physical properties of production of polyether polyoil from the in situ hydrolysis. So this actually to what we call to prolong the time of epoxidation. Actually, we will from 118 minutes to 330 minutes to ensure the ozone ring will fully complete react with the water via in situ hydrolysis process. Second one, to every 30 minutes need to analyze the OH value of polyoil, molecular weight of polyoil, also iodine value to ensure the best quality of polyoil. So they have 5 types of the chemical, the physical properties that we have studied is iodine value, molecular weight, RCO, hydroxyl value, and thermal degradation. Okay. So the result from the research. For objective, the synthesis of epoxide from the pure edible oil and 100% waste cooking oil. So, from objective, we study compare the RCO that produced from both different type of oil. So, both experiment was conducted using the parameter number 1 molar ratio HPOA11, number 2 is molar ratio FAOA11, number 3 agitation speed 300, and number 4 is reaction temperature 85 degrees. So this is the best optimal parameter that we have found. Then the graph shown that the POWCO is the higher RCO compared with the 100% WCO because of the palm oil have the higher percentage of unsaturation compared to the waste cooking oil. So result number 2, the synthesis of epoxide from different ratio of palm oil waste cooking oil. So method is we select 3 ratio of hybrid palm oil plus waste cooking oil by manipulate percent of the ratio POWCO 50-50, POWCO 30-70, and POWCO 70-30. The parameter keep constant, and the graph shown that the highest RCO at 70 palm oil and 30 WCO compared with the 50-50 and 30-70. So this is the result of the optimization. So optimization process, we use the SN ratio. So SN ratio actually the ratio between the desired percent of product to the undesired signal or noise. So the higher SN is the best result and better quality and better performance. The best result is the higher signal. The higher signal better than lower. Optimization was conducted to find the best value parameter, such as for the HPOA, second to FAOA, third for the agitation speed and room temperature. So this we call the SN ratio that we have run based on 9 experiments. So as we see that from the table, they have from the SN ratio, the optimum parameter produce RCO from the group A, which is molar ratio of HPOA, which is level 3, 1.51. For the B, molar ratio of FAOA at the level 3, using the 1.5 molar ratio. The C, agitation speed is 200, which is level number 1, and D is 85 degrees, is level number 3. So the SN ratio used to use the large is better, is significant for this study. So ANOVA to verify the percentage of contribution of level in population, we want to check either hydrogen peroxide played a major role to production of epoxide, or either formic acid, or either strain agitation, or either reaction temperature. So ANOVA to check the contribution of the level population. So the highest contribution based on the result is from the hydrogen peroxide, which is 92.17%, while the lowest contribution is the temperature. So the reason the higher from the hydrogen peroxide due to the low undesired product produced. Then the hydrogen peroxide is very, very form nucleophilic and higher rate of attack double bond unsaturated of fatty acid. And then reaction temperature is lowest contribution due to the undergoes the exothermic. Exothermic process release the heat causes the temperature increase suddenly inside the reaction and not required to heat up back the process reaction. The effect of the molar ratio of the hydrogen peroxide to oleic acid. So So we have studied from this 3 experiment was conducted by manipulate molar ratio of the hydrogen peroxide to oleic acid 0.5 to 1, 1 to 1, and 1.5 to 1 with constant as parameters such as molar ratio, speed, and also temperature. So the graph comparison as below. So from the graph shown that the higher hydrogen peroxide causing the increasing the formic acid performance of increase able to create the higher nucleophilic to attack the unsaturated double bond to increase the formation of peroxide and also increase the RCO formation. Okay, second one, to study the effect of molar ratio on the performing acid to oleic acid. So also we have conduct 3 experiments to manipulate the molar ratio of formic acid to oleic acid, but with the constant of other parameters such as HP ratio 1.5, speed 200, also temperature 85 degrees. So from the comparison, they have shown that the higher RCO during using the FaOA 1.5. This because this optimal parameter to produce the higher performing acid, they are able to convert unsaturated double bond to epoxide with minimize the ozone cleavage. The third one, to result of the string agitation and RCO formation. So also we run the 3 experiment and we manipulate the string speed with the constant others parameter HP, Fa, and also the temperature. So from the graph shown that the RCO, high RCO using speed agitation 200 as the optimum process, which the optimal speed is not too slow and also not too fast. They're able to give the good distribution of heat to the process and increase the rate reaction. To high speed also able to reduce RCO because it also increase sudden temperature because the existing process also undergoes the exothermic reaction. So this is the FTIR for epoxide based on Taguchi method. So from this figure we can compare the epoxide also the hybrid oleic acid. Okay, so based on this result, it's shown that the OH is formed at the 3104 wavelength, which is OH value is indicate the formation group of polyoil. Also see double bond C stretching at 2998, which is this group indicate they have a group of the epoxide which is start to break the bond to produce the ozyrine. Also CH stretching and for CH3 and CH2 it formed on the 2900 cm, which is indicate they have formation of a polyoil group. Also indicate have the group of the oleic acid. And C double bond O stretching at the 1706, which is indicate the group of the polyoil. And also C double bond C is actually is a group of the epoxide, indicate the group of epoxide. So the second the others result is the physical properties of biopolyether polyoil. So we have run studied the comparison between the RCO value, polyoil hydroxy value, iodine value, and molecular weight versus time. So from the table shown the best polyoil at 330 minutes, which is produced the higher molecular weight but lower OH value. So according to the study and the previous study, the polyoil can produce flexible PU and contain polyether polyoil. So based on the graph, you can see that our data that shown here shown that the product is we produce is the flexible PU because if we see the molecular weight they have higher than 1000 gram per mole higher, and also you see the polyoil hydroxy value is lower than 200. So this characteristic indicate that this polyoil actually is fall under the flexible polyoil as a flexible PU. So the best is at 330 minutes, which is during that time the iodine value also dropped to 22.6 from 30.2, which is indicate that the unsaturated double bond already less compared from the initial, which is that the oleic acid completely react with the hydrogen with the formic acid to produce the epoxide. Also, epoxide already cleavage the oxy ring to produce the polyol. Also, you see the polyol itself, they have a lower OH value at the end of the process, which is give the best flexible PU characteristic when having the lower molecular weight. Okay, so this is a list of paper that we have carried out there for paper. So that's all from me. Thank you.